200-something thousand people drove by this morning and had no idea history was being made. And we made history on the Benicio Martinez Bridge, made history on the retrofit of the Golden Gate Bridge, and this, I think, is going to be the signature bridge in the Bay Area. It may not overshadow the Golden Gate, but the engineering and the talent that it takes to build this bridge, it's really satisfying to be part of that.
There's only 3 other self-anchored bridges in the United States. They're all 3 in Pittsburgh, Pennsylvania. They were built back in the early part of the 19th century. So this is probably the first self-anchored bridge that's been built in this country since the 40s, and it will be the largest single-tower self-anchored suspension bridge in the world. That may not mean a lot to Joe Blow on the street, but basically that drives all the construction means and methods. How this bridge has to be built is largely dictated by the self-anchored nature of the bridge.
So the work process, that's what you're talking about for this bridge, is very different than most other bridges.
How the bridge is built, the process of building the bridge is very different. The fact that we have 25,000 tons of temporary steel on this bridge supporting the bridge temporarily until we can get the cables up and go through a load transfer is very unique.
There are several seismic innovations that we've done with this bridge. The tower section that's going in today, right now behind my back, is sort of a part of that. The single tower that we're building for the self-anchored suspension bridge is actually broken up into 4 independent legs. The reason for that is that in a massive level earthquake, the largest earthquake you'd see happening in 1,500 years is what we're designed for. These tower legs can move independent of each other, not together, and they won't break. But the pieces that are connecting them act like fuses. They're sacrificial members that can bend, they can crack, and then we can just unbolt them and put new ones in after the earthquake.
So what you're saying is that this is a replaceable legs on the bridge?
Well, the legs won't be because they won't take the damage, but the things that connect the legs together that make it one tower, those will actually pop out. So it's the concept of putting a fuse, like the fuse in your car, into a bridge.
And has this been used before?
No, this is the first time that it's been done. This morning about 6 o'clock, we started lifting a 1,200-ton, 165-foot tall section that is the first part of our signature span for the world's largest self-anchored suspension bridge. And you can see it right here behind me. It's already vertical, it's being unbolted, and it's going to be slid into place and set down onto a foundation where it will stand for at least 150 years in the next few hours. Now what we have to do is move the piece inside of that metal framework you see and set it down on top of the foundation for the bridge. And so what you see here when you look at this tower piece, there's some dark areas. Those are the parts where our shear link beams will connect all 4 of the legs that make up this tower. And those beams actually act like fuses in a very large earthquake. In a massive earthquake, these tower legs can move independent of each other, and those beams will bend and contort and break. We can simply unbolt them and rebolt new ones in after an earthquake, so that the bridge can remain open for emergency services. First piece is about 165 feet tall. That's just about right to deck level. The next pieces that we plan to put in October are another 100 feet above that. So it will be very visible to traffic going across the bridge for our next sections. In place, the single tower for our signature portion of the east span of this bridge. This tower is going to be 525 feet tall, the largest of its type in the world, and we're putting the first 165-foot tall section of it in place on the bay today.
Okay, and how long is it going to take for you to put that in place, and how difficult is it?
Right, well the tower is actually made up of 4 independent legs, so this is just the very first piece of one of those legs. It weighs over 1,200 tons. So it's a fairly big challenge to lift 1,200 tons on the water. That's sort of the first part of it. The operation was designed to take about 12 hours because it has to move very slowly so we don't generate too much momentum.
And this is the first of how many?
This is the first of 4 in this shipment. So all 4 pieces will be put in place, and then we have 5 lifts just like this that we will need till we get to the top.
I've been in this business for over 35 years, and I can assure you that the capability of building this structure as quickly and as cheaply as we needed to in this country did not exist, and to this day does not exist.
What does that mean?
It means that there are no fabricators in this country that have the capability of building the elements, the pieces that we see in place on this bridge in America. That capability has passed us by.
So do you think America will ever catch up?
I think that the only way America can catch up with what I'm seeing in China right now is huge investments in new fabricating facilities, which most likely would have to be at least in part funded by the government.
And there were ships. This had to be designed for ships to bring these things here. Why don't you talk about that?
All the elements come on board ships. There are anywhere from 8 deck sections to 4 tower sections that come on board each ship. As originally planned, we had 8 different shipments coming by ship from China. We actually purchased some of the false work also from China, so there will at the end of the day be more than 8 ships, probably more in a line of say 12 ships, but it all comes by ship. Any place this would have been fabricated, it would have had to come by ship. These pieces are gigantic. They're just far too large to ever ship in any other manner. You can't truck these pieces. They're massive.
What percentage of the bridge has been fabricated in China?
I don't know the breakdown for that. I can go the other way. 75% of the steel fabrication was done here in the United States, so we're about 25% of foreign steel. A good part of that 25% is Chinese because all of the deck sections of the tower and the main cable are coming from China, but there are key elements that are coming from other countries as well. Japan has provided us with the saddles that the cable actually will sit in. And then the suspender cables are American made here. And then we've got some German technology and Italian technology that we have used in some of these different operations.
So you're saying it's really an international bridge?
This is most definitely an international bridge. It takes the world to build something world class at this scale.
I'm on the Transportation Commission in the state of California. And the one thing that we lack, that I think is the most important key to the whole thing, is a dedicated funding source for not only rehabilitation but expansion. So until we get that, it's going to be hit and miss. When the money's there, you build. When the money's not there, you can't build anything. The commission, the term of the commission prior to my coming on board, there was a full 4 years. They never approved a single project. You've got to have a dedicated funding source. And then you'll see, if the political will is there, you'll see the expansion, you'll see the rehabilitation, you'll see even just basic maintenance being accomplished.
So you're saying it's possible really to have a building program and development program to rebuild America?
There is. Once you have the political will and you make that commitment, not only making that commitment to fund the original construction, but the maintenance and the rehabilitation has to follow. It's just like buying a house. You can buy a house and make that first investment, and if you don't keep good care of the house, it's going to fall down around you. But every homeowner knows, at least once a month, you're going to, even if it's just cutting your lawn, you're going to have minor plumbing repairs, you're going to have minor electrical repairs, you're going to just fix a door, fix a window. As long as you keep up with those small little things, it's not going to fall down around you. No difference between that house and that bridge.
And how is the infrastructure of California? I mean, specifically, what needs to be done to rebuild it and maintain it?
Well, I don't have the numbers, so I don't want to quote them right off the top of my head. But if you go to the Transportation Commission report to the legislature, you'll see that there's X amount of miles every year that fall into disrepair, and it just keeps building and building. And at a certain point, when you don't repair a road, then it comes a point where you can't repair it and you got to tear it out and rebuild it. So it's easier, it's cheaper, not easier, it's cheaper to maintain a road or a bridge than to let it fall in such disrepair that you have to rebuild it. So the commitment has to be, that political will has to be there to make that commitment that, okay, let's build this bridge, but then let's put aside X amount of dollars a year to maintain it. Let's build this road, then let's put aside X amount of dollars to maintain it.
Safety is key. I mean, safety is the first thing we talk about every day. You know, it's enough said. It's the most important thing to us on a daily basis. Our safety record has been very good on this project, and it will continue to be good because we pay a lot of attention to it.
My name's Justin Garrett. All the tugboats are doing is they're holding the barges in place with going against the current, so it doesn't get out of whack and ruin the fit.
And what kind of training do you have to do this kind of work? And how did you get your training? Did you go to apprentice school, or how did you
I started out on the tugboats on the Santa Fe Richmond job, and I just learned by just doing it.
How many operators are there working on this bridge?
I think we have 8 to 10 licensed boat captains, and then that's for West Diving that runs the boats. Is subbed out to do the boats. And then for ABF and Floor, I'm not really sure how many operators they have.
So have there been any accidents?
Not that I've seen, not since I've been out here. It's been pretty good.
What about the weather? Has that affected your work here, or was it different weather, different conditions, and how does that affect?
Sometimes if it gets too windy and rainy, you'll have to shut down because the cranes will get on. The loads will be moving around on the crane a lot, and it'll be hard for the iron workers when they're up on the iron trying to hook things up, especially the false work when they're doing that. But like today, this is a good day. This is nice.
And how many different unions are involved in this project?
I think every one of them. I mean, pile drivers, carpenters, millwrights, electricians, laborers, operating engineers, we all got a piece of it.
So it's a united effort of labor to get this thing built.
Absolutely. And you have pride in your own craft, but you have pride that you bring to the job. And when you see another person struggling, you don't stand there and watch them just because they belong to another craft. You reach your hand out and you help them. That's why we've done it for hundreds of years. That's why we're going to do it for the next couple of